So for this extra calculation example then, for the probit model, so the same basic question, what's the success probability if loads of 1,999 kilograms and 4,891 kilograms are applied? So again, in R, this function z-1 that you need is calculated using the command pnorm. And what you do is apply this function to the equation, which should this. So I've done here z-1 374349. That is just applying in R the function pnorm to this number 1.374349. So you get 1153333 in this case, and then it's exactly the same way for the second calculation. So this function applied to the output of the regression equation. So the function pnorm in R applied to this number here, minus 1.369581, that is 0.8540887. So these are again much more sensible probability estimates. It should roughly match the values you get from the logit model. So similar models should give you similar numerical answers. And note here, probability 5 less than 1. This probability here, 0.85, much more sensible, greater than 0. So in summary then, the linear probability model is surprisingly popular, but not really a viable model, so please don't use it. The logit model and the probit model are more viable ways of regressing and estimating probabilities, so do use these. In our numerical example, the linear probability model does give reasonable probability estimates in the middle of the sample, but it's liable to break down both extreme cases when you've got probabilities either close to 0 or close to 1. And it's precisely when you've got probabilities that are close to these boundary cases where these probability regression models will come into their own. As part of that, in practical examples, you'd usually expect to see similar numerical estimates for probabilities from viable models like the logit model and the probit model. And I think there's an element here which you need a bit of practical experience to fully understand. It's not just a purely mathematical and statistical thing. So the idea is that if you use numerical estimates from a logit model and a probit model, this would give a sense of robustness to the results obtained and their interpretation, precisely because similar models should give you similar numerical answers. Okay, and I've not always had the experience to fully appreciate the utility of this. If you've got similar models giving you similar answers, then they provide a cross-check of each other, and that's really important in applied project work.